Assalamualaikum warahmatullahi wabarakatuh and good day. So in this video, we continue with the function of random variable, chapter 4, and we are talking about the method of distribution function. Okay, this is another example and it's focused on bivariate situation. So consider that we have y1 and y2, a random variable with joint density function of this one, fy1, y2, okay, and let u equal to a function of h with y1 and y2. Then, for every point of y1 and y2, there's correspond one and only one value of u. Okay, so that's mean you have point y1, y2, and this point is correspond to one and only one value of u. And if we can find the region of values 1, 1, y2, such that u is less than equal with u, then the integral of the joint density function for y1 and y2 over this region is equal with the probability function of u and equal with the distribution function of u. This is what we want to find. And in order to find the density function of fu, you can use it or you can obtain by differentiate. Okay, so the step is similar like previous video, but here we have two random variables, y1 and y2. Okay, so now look example 6.2, page 299. In example 5.4, okay, this one we have done before in previous chapter. We consider the random variable y1, which is the proportional amount of gasoline stock at the beginning of the week. And then y2 is the proportional amount of gasoline sold during the week. Okay, y1 is gasoline stock, y2 is the gasoline sold. And then the joint density function for y1 and y2 is given by this equation. So it's equal with 3y1, and you can see that y2 is less than y1, and then y1 is between 0 and 1. So you can see that the value of y2 is less than y1, okay, because y2 is the gasoline sold, should be less than value of y1, which is the gasoline stock at the beginning of the week, okay, and then both value is between 0 and 1. So the question asks you to find the probability density function for u, which is equal with y1 minus y2. So this is the function u, okay. The proportional amount of gasoline remain at the end of the week. So y1 minus y2 is the balance, okay, because y1 is stock, okay, the gasoline stock, and then you minus with the gasoline sold. So you can see balance how much is the gasoline, okay. So use the density function of f of u to find the expected u. So if you look here, this one we want to find the f small fu, okay. So that's the first thing that you must know how to find, and then by using that one you will find the expected u. So if you look at the solution, okay, this is the figure, okay, you can see that the region over which fy1, y2 is not 0 is sketched in figure 6.1. Okay, so you can see that at previous slide, we know that our y1 and y2 is between 0 and 1. Okay, this one, let me show you. This one, you can see that your y2 is less than y1, but both value y1 and y2 is between 0 and 1. Okay, and also shown the line is y1 minus y2 equal to u. So you can see that, okay, you will have y1 minus y2 equal with u for the value of u between 0 and 1. So this one, actually you can try. Okay, if your y1 is equal to 0, y2 equal to 0, for sure you get u equal to 0. Okay, but if your y1 equal to 1, y2 equal to 0, you will get u equal with 1. If you have y1 equal to 0 and y2 equal to 1, you will get u negative 1. Okay, and notice that any point y1, y2 such that y1 minus y2 less than u lies above the line of y1 minus y2 equal to u. Okay, if you look this figure, okay, because we have this one, isn't it? We have fu. Okay, in order for us to find the distribution function of fu, we will have p u less than u. So this one you will substitute the p, which is y1 minus y2 less equal to u. Alright, so this one, this equation actually, if you put, you will have y1 equal to y2, which is this one lah. This one. Okay, this is y1 equal to y2. Alright, and then you have y1 minus y2 equal to u, this one. Alright, okay, let's say that if u less than 0, okay, if u less than 0, the line y1 minus y2 equal to u has intercept of negative u, which is less than 0. Okay, that's mean if you just put here negative, let's say u is equal to with negative 1. Okay, negative 1. So we can see that the intercept of this one, y1 minus y2, will be negative value of u. Okay, and then the distribution function of fu will be equal with 0. Okay, but when your u is greater than 1, okay, let's say 2. Okay, so this line, okay, this line will give you intercept of negative u less than negative 1. Okay, so based on this one, you will get distribution function of u equal to 1. Okay, so for u between 0 and 1, okay, because you can see u is here, is between 0 and 1. So the fu, okay, the distribution function of u can be integral over the dark shaded. Okay, actually here lah, the dark shaded. Okay, between 0 and 1. So this is the value, the dark shaded. Okay, region above the line y1 minus y2 equal to u. Okay, however, in order for us to find easier integration, okay, we will integrate the lower shaded, the lower region, this one. Okay, which is for u between 0 and 1. To find the distribution function of u, for u is between 0 and 1, okay, we will use, or we will integrate the function of y1, y2. So mentioned before, the area shaded for u less than equal to u is above the y1 minus y2 equal to u. So it's difficult to get the limit. Then we use 1 minus probability u greater than u. Okay, why 1 minus? Because it's a probability, so it should be 1 minus something. Alright, so this one less than, here should be greater than u. Okay, so if you look the figure here, you can see that your y1, this area is between u and 1. Okay, and then for y2, how you get? You will get from here, which is y1 minus y2 equal to u. So here you will get y1 minus u equal to y2. So here it will give you from 0 until y1 minus u. So because from the beginning, the limit of here is 0, y2, y1, isn't it? Alright. So if you look here, you can see that you have y2 less than y1, and then it's between 0 and 1. That's why for y2 it's between 0 and here is y1 minus u, and then for this one it's between u until 1. Okay, so that's why we have here. Okay, for y2 is 0 until y1 minus y2. Okay, because the limit of u is between 0 and 1. 0 and 1 here. Okay, but in between two, so for y2 is 0 until y1 minus y2. And then for y1 is between u and 1. So integrate as usual. Okay, this one with respect to y2 and then with respect to y1. And then you get this equation. Okay, so in order to summary this one, you will have this one. Remember previously we mentioned if u is less than 0, the distribution function of u, you will get 0. If u greater than 1, the distribution function of u is 1. And then for u between 0 and 1, you will get this equation. Okay, so this is the distribution function that we want to find. This one also can be shown by using the figure 6.2. So this is the distribution function. You can see that you have u is between 0, 1, 0, 1 as well. So you can see that if u is less than 0, it here 0. If u greater than 1, it will be 1 here. So for in between 0 and 1, this is the graph. Okay, so that is the distribution function. Now the density function. So in order for us to get the density function, okay, small f, we will differentiate the distribution function. So when you differentiate 0, you get 0 lah. And then when you differentiate this one, you will get 3, 1 minus u square over 2. Okay, this one differentiation. Okay, so the limit is similar. And then if you differentiate 1, you get 0. So this is the density function. And then the density function, okay, the graph can be shown like here. Okay, you can see that from 0 to 1, this is the value. Okay, you have half here, okay, because over 5 over 2. Okay, you will have 3 over 2 is 1 over 5, so it will be here. All right, so and then you can see 0 is elsewhere. That's when other than that you get 0. Now the second question is use the density function that you get to find the expected u. Okay, so again, this one has done before. That's mean if you want to find ey, you will have y f y, isn't it, dy. So similar for this one, you want to find eu, so you have u and then this is your fu, the density function, and then du. So what is the limit? 0 until 1. So integrate as usual, then you get 3 over 8, okay, which agrees with the value of expected y1 minus y2 found in example 5.20. This one you can check, okay, you get the same value for this one, okay. But that one is using a method in chapter 5, okay, finding the expected value of a linear function of random variable. Alright, so I think that's all for this video. Okay, you can try another example or you can try an exercise. Okay, alright, so thank you, class.